When you press power button to turn on your PC, microprocessor wakes up and gives its control to BIOS to make ready the PC for you. Now why it passes its control to BIOS? Look, processor is a piece of hardware which is connected to the motherboard at the time of manufacture or at the time of assembling a PC, but it knows nothing about the architecture of the motherboard. It can hold nothing as its cache memory is a volatile memory. Hence, there must be something that knows everything about the architecture of the motherboard. For this purpose, motherboard manufacturer designs a customized software as per the architecture, with the help of a low-level programming language known as assembly language, for booting up and connecting the hardware to its operating system. This software is called BIOS. Since BIOS is a software, so to hold this software, he needs a special type of non-volatile memory component. But hard drive or SSD do not have that type of memory that the manufacturer wants to use for storing BIOS. And RAM is a psycho memory too. It forgets everything after computer is turned off. So he chooses a tiny EPROM chip and installs BIOS into it. The EPROM chip is a non-volatile memory chip that can store BIOS permanently. Now it is fixed onto the motherboard. After fixation onto the motherboard, this chip is called BIOS or BIOS chip or computer firmware. Anyway, after getting controllability from the microprocessor, BIOS starts its booting up process. This process goes through 4 main steps, and finally it makes ready the computer for you. These steps are explained in the previous video. The link is in the description. Though it has been working very smoothly since 1980 with the name of Legacy BIOS or Traditional BIOS, it has some limitations recognized by Intel. And instead of this, Intel introduces a new type of BIOS called UEFI BIOS. So Intel PCs are moving away from Legacy BIOS towards UEFI BIOS. Now what is UEFI? The Unified Extensible Firmware Interface, in short UEFI, is an interface program, or you can say a specification that connects the computer's firmware to its operating system. It is written in C language. It does the same job as BIOS at the time of booting, but offers more features and can be extensively customized. Now what are the limitations for which Intel wants to move away from Legacy BIOS towards UEFI BIOS? The first limitation of Legacy BIOS is non-recognizing drives that are larger than 2.1 TB. Size of media files are increasing over the time. It's needed to keep larger storage drive. Legacy BIOS uses master boot record format, in short MBR, to access into your hard drive or SSD. And one limitation of this format is it can't recognize drives that are larger than 2.1 TB. So, if you connect a hard drive which size is more than 2.1 TB, MBR will not recognize it. On the other hand, UEFI uses GUID partition table format, in short GPT, and it can support drives of any size available in the world of technology. But theoretically, there has a limit of 9 ZB. MBR has another limitation for which we cannot create more than 4 partitions in drives. This is the second limitation of Legacy BIOS for using MBR format. On the other hand, UEFI is able to create up to 128 partitions for using GPT format. The third limitation of Legacy BIOS is it runs only in 16-bit processor mode and it has a very low space of memory to execute. So while booting, it can't initialize multiple hardware devices at once and initializes them in sequence, which slows down the booting process. On the other hand, UEFI can run in both 32-bit or 64-bit mode. That means it can run in any mode whatever the processor and the OS have. Hence, the UEFI gets more addressable memory space than BIOS, for which it can initialize multiple hardware devices at once, and thus computer boots faster. Along with these, UEFI offers several features and advantages which are not with legacy BIOS. For example, UEFI has a built-in feature of secure boot, meaning that every time you turn on your PC, UEFI checks the OS for malware and rootkits. If any found, then it prevents them and allows only the authentic OS to be run in your PC. UEFI also supports networking features within the firmware, which enables the user to configure and troubleshoot issues remotely even with no operating system installed. One of the most attractive things in UEFI is it provides an user-friendly graphical user interface that's full of different colors and animations, and it supports mouse also, along with the keyboard. Whereas traditional BIOS only featured with blue screen and white or yellow text, and mouse support wasn't available. BIOS needs and allows only a single bootloader, which is stored inside its chip itself, containing all the initial data of a single OS. But UEFI stores all the data about initialization and startup in an .EFI file on a special partition called EFI system partition on the drive, instead of storing them on the firmware, and lets the users install multiple loaders from multiple OS in the same EFI system partition. This is the main reason why UEFI operates differently from BIOS.